Hello, everyone. Good morning. My name is Hussain Alsalem, and I'm from Saudi Arabia, from the University of Imam Abdulrahman bin Faisal in Dammam, Eastern Province. As this presentation is titled Laboratory Access Implementing QR Code Authentication using OTP. I'll go to step by step. So as an introduction, QR code, which is the shortcut of quick response code, is used in many different uses. But our focus in this field is to use QR code in a safer and more effective way to organize and manage the entry of laboratories or any organization. But here we focus mainly on the college after the working hours, the laboratory of the college after the working hours. So the idea description, our idea is to use an encrypted QR code with an OTP authentication that will be connected to a LAN network to guarantee that each student entrance can only use a single PC. Students can check labs status from a web application. So here I can say mainly our idea will divide into three parts: a web application to see the status of lab and to request the QR code. And the second part will be the Python code to verify and to manage the authentication. And the last part will be for the hardware and the hardware parts. The problem statement, college have laboratories that used for teaching during working hours. To make more use of these laboratories after working hours, students can use these labs to study and do their homeworks. In order to control the access of laboratories, we need a safe and convenient way to ensure that these laboratories are not used by unauthorized users. So we have set three main objectives. The first one, to make use of a QR code in a more secure way. And the second one, to organize and manage the entry of college laboratories. And thirdly, to make the process of finding available seats at labs faster and convenient. In the literature review, the first part, I will talk about the QR generation. So at the beginning, there was no QR code. There is a barcode developed in Japan by Denzo Wave and Mashiro Hara. They worked on it to help grow the Japanese supermarket to keep track of their products. But the problem was here. Barcodes only hold a limit of 20 alphabetic, which is made companies struggle. So in this picture, we can see the development of the barcode into QR code. And here, for example, at the beginning, from the 1970, you use a UPC code, and generation after generation, they got to hold more and more data into it. And here is more see on the structure of the QR code. So we have a function pattern and the QR code version and capacity and the QR code error correction. Here in this part, the first part is code about the coded zone, and here is the function patterns. We can see the finder patterns and the separator and timing pattern, and here the alignment pattern to see the alignment of the QR code. And here in the down, we can see the encoding region. Here, the version information, which we have mentioned it here, and also format information. And here is one of the important part, which is data and error correction code words. And EQR with ASOTP, user credential are used for encrypted QR generation. So credential is used as OTP encrypted with an EES 256-bit key and password for check-ins. One-time password OTP. A one-time password OTP provides a way to log in to surfaces with a unique password that can only be used once. Implementing OTP in your system or in our system will prevent a lot of attacks by default. For example, eavesdroppings and denial of service and dictionary attacks. Here we see the structure of the OTP, which is HMAC-based one-time password, and an event-based of OTP, where the moving factor in each code is based on a counter. So as we can see here, we start with a key and a counter of 8-bit, and then the message has function and all the steps. And we can see also in the divided in two parts, client part and the server part. And we can see here in the server part, we do the same process that we do on the client side to make sure that the OTP is exactly the same OTP that we have received from the client. If they are the same, you will be authenticated. If you are not, it will be rejected. Here, the TOTP, which we have, is a temporary password generated by an algorithm that use the count time of day as its moving factor. So we can see here, it is also here we can see the part of the HMAC, which we have talked about it before, HMAC, and the token time. And instead of using a counter, we will depend on the current time to generate the OTP. The differences between the HOTP and TOTP, the moving factor, as we have mentioned it before, and the synchronization problem that we have solved by using the current time and the availability of the OTP, and finally the security aspect, which we have talked about also. Using the time is more dynamic and not more dynamic. It is dynamic rather than use a fixed counter. Here we will talk about the text detection. Nowadays, technology is evolving and entering data to the database manually is considered as a tedious work. The concept of detecting a text inside an image is challenging due to many factors, such as different type of text, font, and size, and image clarity, and varied in lightning situations. Here, one method of text detection, it's called stroke width transform, uses stroke width transform, which is a characteristic that distinguish a text from other elements in the environment. So in the left image here, we can see the SW, which is the stroke width transform calculations. And for more information, we can see this paper. Also on the left side, the operator of the output. So here is the first image, and here is after the processing. The other method is called edge enhanced maximally stable external regions. The negative side about the MSER is that it is sensitive to image flow. We can enhances the outline of external regions and eliminate MSER pixels that's out of the scope. Here is an example. In the upper picture, sorry, MSER representation, there is one problem here. Sometimes it can differentiate between the two letters if they come immediately after each other. So here it considered the double E as one E. The last method of the text detection, which is the better of the previous two, it's OpenCV and TIS-RCAT. OpenCV, Open Secure Computer Version, this is the full name, offers a set of functions that help in processing an image. Then proceed image is fed to TIS-RCAT software. Actually, this is, we can use it on Python language. and we have used it in the Python. Here is a small comparison between different type of encryption. For example, the DES and the RSA and AES with the different papers here also. So we can notice that the AES, it is the level of security excellent, and it is faster, and we have different key size. For example, the most secure one is on the point of our research was 256. The rounds here, it doesn't mention it in this paper, but we can see different rounds for different type of encryption. And here also a small comparison between different type of the HOTP and the TOTP. We can see the OTP, the duration is short for TOTP and high in speed. Here it is the average server response time. For HOTP, it's 1.75 seconds, and for the TOTP, it's 1.25 seconds. Here is just an overview of the design. So the users of web application, as we have mentioned before, it has two functionality. The website, either to register and request the QR code, or to see the lab status and how many seats available. And the other parts will be for the program itself. So when the user wants to enter, he must scan his QR code. If it is not valid, he will ask him to ask the user to scan their QR code. And if it is valid, it will have 3 trials. If the OTP is valid, not valid, each time it will increase the counter. And lastly, if he doesn't got it correctly, he will be suspended for a specific time. And lastly, if he got it correctly, he will be able to enter the lab. Lastly, I want to mention the architecture of this project, or this idea, to be more clear. Here, the user will request the QR code, and the server will respond with the QR code. And here the user attempts to access. There is an authentication server. He will send the OTP and verify the OTP. If it is correct, the student will be allowed to enter to the lab. Here is the main components of the projects, which is the Python language. We use it to verify the users. And we have a LAN network that will be a wireless LAN network and will be managed by the system. Also, we have used a Microsoft SQL Server for managing the database. And we have used the HTML and JavaScript and CSS to program the website. And lastly, we use Arduino parts to try and have a prototype of our system. And that's the end. Thank you for listening. Is there any question?